Hi, welcome to your video on linear, quadratic, and exponential models. You will be able to choose a linear, quadratic, or exponential model for data that you are given. Here's a quick review since it's been a little while since we talked about some of these. Linear, remember, is y equals mx plus b. It is a straight line. Sometimes it will go through the origin, sometimes it won't. Quadratic is y equals ax squared plus bx plus c. Remember, the shape of that graph is a parabola. And exponential is y equals a times b to the x power. And then you can see the graph there. How do I determine what equation model to use? So you'll be given different tables, and there's 3 examples here, and then you will have to determine whether it is in fact quadratic, linear, etc. So what you want to do is find if there is a common difference or a common ratio that you can use. In this first example, you can see, and then I just want to point out that these little X signs are just negatives. That's what it means, so it just looks funny. But here we can see that X is adding by 1 every time as we go, and then Y is adding by 3 every time. That is a common difference. The Y values have a common difference of 3, so this would be a linear model. Next one, I guess I should probably write linear on here. Linear for that one. Alright, the next one. Here we have first differences are listed here, and you don't really see a pattern as you go. First it's minusing by 1, then adding 2, then adding 6, then adding 10. Not too much of a pattern. But if you go one more difference further, you can see going from -2 to 2 is 4, 2 to 6 is 4, and 6 to 10 is 4. There is a second difference set because you're going twice. And when that happens, it is called second differences. So this would be a quadratic model because of the second differences. Last type of one that we're going to talk about here is that you can see each time if you're not adding or subtracting or anything, there isn't a common difference. There is a common ratio, and the ratio is multiplying by 2 every time that you go down the y column. And so because of this would be considered a common ratio, so it is exponential. The next question is, how do I model data? And this is the most important piece. When you are given a table, something that looks like this, ignore the red writing for now, but when you have a table here, the first thing you'll want to do is graph the data. The reason for that is with graphing you can kind of see what's happening. So if we graph the data points in that table, you're going to get something that looks like this. And just from looking at this, you can tell that it might either be quadratic, and it should be quadratic. It could also possibly be exponential. It kind of looks like either one, but you're not sure. So what you want to do is go to your table next and find either a second common difference or a common ratio. And you can see by looking at this that it is a common difference of 1, a second common difference. So you know that will verify the fact that it is quadratic. After you know that, you'll want to write a equation, and because you have discovered that it's quadratic using both the graph and the table, you're going to use the graph, which is helpful to know where the vertex is. So you know in this case you can use y equals ax squared because the vertex is at 0, and then you can plug in a point, whatever you want. any point that is given to you already, and you want to be specific. So any point that comes from the table. In this case, it was the 2, 2 point right here. But you could have picked the 3, 4.5. You could pick the 4, 8. It doesn't really matter. Anything on that table you can use. You're going to use that to find A. So then you evaluate and you end up seeing that A is 0.5. So then you would write your equation y equals ax squared with your A being 1/2. And there's your quadratic function. I'll give you a real life situation because this does happen in real life. Here's a transportation problem. It says the data at the right gives the value of a used car over time. So we want to know what happens. So if we look at this table here, we want to first, it's always nice to graph the data right away and then use the table just because it gives you an idea. So when I graph this, I get this. And I can see the chances are that it's going to be exponential. It doesn't really look like a parabola. It could maybe be linear, but it doesn't really look like it. So graphing gives you an idea. And then we can take that table and find a common difference or a common ratio. Because we suspect that it is in fact exponential, we are looking for a common ratio. And as you can see here, that's what's tried. It does have a common ratio of roughly 88 hundredths times being multiplied there. It's not exactly exact, but it's very, very close. So it's roughly that common ratio. Once we know the common ratio, we can write an equation. We use the exponential model, which is y equals a times b to the x. A, remember, is your initial value, your starting amount, and in this case, the starting amount was 12,575. B is your decay factor, in other words, your ratio, and it's called decay, if you remember, because it's decreasing, so it's decay instead, and that would be your common ratio, which is 88 hundredths. So then you would write your equation, just like you can see here. It is your turn now. The table here shows the income of a theater company. Which type of function best describes or models the data? You have 3 options, and then whichever option you decide, write the equation for that. And I'm not going to give you the answer now. We will talk about it in class. This is the end of your video. Thanks for watching. Have a great day.